Hey folks, let's get ready for that Unit 3 test. Solve the equation sine x equals negative radical 2 over 2 on the interval from 0 to just less than 2 pi. Alright, so we want to know, when does sine of x equal negative radical 2 over 2? One thing that helps me remember is my unit circle. Sine is the y value on my unit circle. So when is that going to be, and which is the height, right? So when is that going to be negative radical 2 over 2? Right here and right here. That's when my sine is negative radical 2 over 2, and that happens at 5 pi over 4 and 7 pi over 4. If I'm looking at these possible answers, I know that's wrong because it has a negative value and my x is only from 0 to 2 pi. Let's see, and we figured out 5 pi over 4 and 7 pi over 4, so ba-boom, that's C. Ooh, solve this guy. 2 times sine of x plus radical 3 equals 0. Well, I'm going to try to get sine of x by itself first, and I'm going to first subtract square root of 3 from both sides, because we get rid of addition and subtraction first when we're solving. So that gives me, I'm going to move over here, 2 times the sine of x equals negative square root of 3. Then I can divide both sides by 2. And we get sine of x is negative square root of 3 over 2. And I'm going to take a look at my unit circle to see, when does sine equal negative radical 3 over 2? Right here and right here. So 4 pi over 3 and 7 pi over 4. And then let's see, how do I get back to 4 pi over 3? If I add, because it's either going to be plus 2n pi or plus n pi, right? So if I just add pi, that's going to bring me 180 degrees around. So that's not going to equal negative radical 3 over 2. I need to go all the way around. That's 2 pi. So it's going to be plus 2n pi. And then same thing for 5 pi over 3. Not 7 pi over 4. 4 pi over 3 and 5 pi over 3. Plus 2n pi, because you need to go full circle to get back around there. So what is that? That's A. Find the exact value of inverse sine of 1/2, or arc sine of 1/2, on the interval negative pi over 2 to pi over 2. Alright, I am also going to look at my my unit circle, because what this is asking me is, what angle has a sine of 1/2? So I can look around and see who's got a sine of 1/2. There's one, and that's all the angles on the unit circle. And let's see, we're on the interval from negative pi over 2 to pi over 2. So pi over 2 is here. Bracket, because we're going to use that. And then negative pi over 2 is back here. So we're really only on the right side of this circle. So that means we're only going to count this angle right here. And so the inverse sine, or arc sine of 1/2, is the angle that has a sine that's 1/2. So the inverse, or arc sine of 1/2, is pi over 6. Ding! Find the exact value of inverse cosine of negative 1/2 on the interval 0 to pi. So now I'm looking from 0 to pi, so I'm looking at the top half of the circle. And I want angles that have a cosine of negative 1/2. Oh, where's my cosine negative 1/2? Right there. What angle is that? 2 pi over 3. Bada bing, bada boom. What expression is equivalent to tangent of the inverse cosine of x? Now, to solve this one, it'll be helpful to go back to square one of trigonometry, or perhaps triangle one. Ba-doom-tsh. Anyway, inverse cosine of x means there's some angle that has a cosine equal to x. What does cosine mean? Well, I remember this. Sol, ka, toa. So cosine, remember, was the ratio of the adjacent side of a right triangle over the hypotenuse of the right triangle, and adjacent to whatever angle we're talking about. So if we have a right triangle, and an angle that we're talking about, then that means that the cosine of this angle would have to be x. And cosine is adjacent over hypotenuse. So I can put anything on the adjacent and hypotenuse, any two lengths where adjacent over hypotenuse equals x. I could put x over 1. That would work. I could put 4x over 4. That would work. Right? Because the adjacent side over the hypotenuse would be x. Well, I'm not the kind of guy to make my life any harder than it needs to be, so I'm going to keep it simple. X over 1 equals x. So we use the inverse cosine to get this far in our picture. But let's go back and try to remember, what are we actually trying to find out here? The inverse cosine of x is going to give us this angle, right? And then we want to find the tangent of that angle. Well, what's tangent? Tangent is opposite over adjacent, which would be this guy over x. So if we could figure out what this guy is, then we'd be good, right? And if I peek over at my answers, I'm thinking, well, maybe it might be this, or maybe it might be 1. Who knows? Let's try to find out. Well, lucky for us, we know this guy named Pythagoras, who figured out this theorem that he named after himself, called the Pythagorean theorem, that says the leg squared plus the leg squared equals the hypotenuse squared. So x squared plus something squared equals 1 squared. So let's see, 1 squared is just 1. If I want to find out what my question mark is, I need to subtract x squared from both sides. So I got that leg squared equals 1 minus x squared, because 1 squared is 1. And then to get question mark by itself, I just take the square root of both sides. So what is that leg? It is the square root of 1 minus x squared. So this leg has to be the square root of 1 minus x squared. And now I can find the tangent of this angle. It's just opposite over hypotenuse, which is A. A! I didn't really need this today. Well, on this problem. I needed it today, just not on this problem. Find the approximate value of inverse tangent of radical 5 on the interval negative pi over 2 to pi over 2. This time I probably ain't going to need this. So inverse tangent means what angle gives me a tangent of radical 5. And I'm only on from negative pi over 2 to pi over 2, so I'm only on the right side of the unit circle. All right, and so tangent is, another way to think of tangent is sine over cosine. So, look at my answers. My answers are all decimals, which means this guy isn't going to do me a whole heap of good because these are decimal approximations. When I have decimal approximations, I get to use my calculator. Alright, so I have my magic calculator ready to go. Here's my tangent. The little blue guy above it is arctangent or inverse tangent. So I'm going to do second. And that gives me inverse tangent. And then square root of 5. Square root is right here. Second. Square root of 5 equals 1.15. And then I just got to double check it. Wait, timeout. Am I in degrees or radians? I should be in radians. Okay, good. I'm in radians, because if I wasn't, then these would have little degrees on them. So what would happen if I'd messed up and went in degrees? What would that do for me? If I did this in degree mode, 65.9, and I would pick A and be wrong, because my interval is given in radians, so my answer has to be in radians, not degrees. So I gotta make sure that my calculator is all up in radian mode. And 1.15, and just make sure that's within negative pi over 2 to pi over 2. So what's pi over 2? This is positive, so I have to make sure it's less than pi over 2. Pi over 2 is about, let's see, 3.14 divided by 2 is approximately 1.57, so I'm good. This is less than that. So my answer is, of course, D. Number 7, which of the choices below is not a solution to the following equation? Well, I think if I can get cosine of theta by itself, I'll have a better idea what's going on with this equation. So I'm going to add square root of 3 to both sides. 2 times cosine of theta is equal to the square root of 3. Divide both sides by 2. And I get cosine of theta is square root of 3 over 2.